Another example I wanted to do, 22, which is obviously like 21 and 23, right around there. It says sketch a triangle that has an acute angle theta and find the other 5 trig ratios. So I'm going to sketch a triangle. It does not have to be done to scale. Call any angle you want theta. And the tangent, SOHCA TOA, is square root of 3 over 1. So I'm going to call the adjacent square root of 3, excuse me, the opposite, and then the adjacent 1. All right. Now that I see the 1 in the square root of 3, I think this is probably a 30, 60, 90 triangle. However, I'm not going to redraw it so that it's to scale. I don't really care. I do need to find this other side using the Pythagorean theorem, or because I know it's a 30, 60, 90, I know this other side is 2. But I'll just pretend I don't. A squared plus b squared equals c squared. This would be my c value. So the square root of 3 squared plus 1 squared equals c squared. 3 plus 1 equals c squared. So 4 is equal to c squared. So c is equal to plus or minus 2. Obviously it's a positive 2, so I didn't need to do that. Whatever. So now I need to find the other trig functions. The sine of theta is opposite over hypotenuse. Cosine of theta is 1 over 2. Tangent of theta, I already have that one. I guess I didn't need to write it. Cosecant of theta is 2 over the square root of 3. I'm basically taking the sine of theta and I'm taking the reciprocal of the sine ratio. Should rationalize the denominator here. Now, on the test, you wouldn't need to do this unless I specifically ask you to, but oftentimes on these tests, I would actually ask that. So there's a cosecant of theta. And then the secant of theta, the secant is the reciprocal of that one, which is 2. And then the cotangent of theta is 1 over the square root of 3, which is a square root of 3 over 3. So 1, 2, 3, 4, 5. Oh, 6. Done. That's supposed to be a smiley face. Sorry.